Hi friends, welcome back. Today we will see another video of unsupervised learning. So it is again based on hierarchical clustering. So we have another example on vehicles data, right? So let's see how we can perform in different problem statement of the vehicles data using hierarchical clustering. So basically the data set has information about features of Charlotte extract from the images of different 4 cars, right? Corsi model vehicles were used for the experiment. So a double decker bus, that is Chevrolet van and Saab 9000 and an Opel Manta 400 cars. This particular combination of vehicles was chosen with the expectations that the bus, van and either one of the cars would be readily distinguishable, but it would be more difficult to distinguish between the cars, right? Here let's apply hierarchical clustering. So import libraries and read the dataset using functions .drop NA to avoid dealing with NAs, right? So import pandas as PD, df equals to pd.read csv. We are importing vehicles.csv and using drop NA, so it will directly delete all the drop NA's values, right? Then we are getting df.shape, okay, 8, 13 and 19. Then df.info, so this is the info, integer, float, integer and all. Then df.head, so this is the head values, right? So here you can see we have top 5 rows. Now print plot the dependent categorical variable and check for any missing values in the data. So since the variable is categorical, you can use value counts function. So pd.value counts df of class, so here cars, bus, van, right, all these. Now import matplotlib.pyplot as plt and percentage matplotlib.inline, right? pd.value counts df class.plot kind equals to bar. So here you can see for car we have around 400, for bus it is nearly 200, similarly for van as well. Now pd.value counts df of class.histogram, right, bins equals to 300. So in 300 bins all the classes are distributed, you can see here. Now df.isNA, we are getting sum if there are any sum values, any's NA values. Now question number 3 is standardize the data, right? So that means since the dimensions of the data are not really known to us, so it would be wise to standardize the data using z-score before we go for any clustering method. You can see z-score function to do this. So interest df equals to df.drop class, right, and access equals to 1. From scipy.stats we are importing z-score again. Interest dfz equals to interest df.apply z-score. Now interest df.z.head, so here you can see that this is the head of our interested dfz. Now from sklearn pre-processing we are importing standard scale to scaling it, right, importing numpy as np. Sc is equal to taking this standard scalar function into this variable x standard, so we will apply the fit transform in interest df, right, so in this standard scalar function. Second time if we get xtd all rows and second column, so here you can see that. Now fourth is create dataset using multivariate normal distribution to visually observe how the cluster are formed at the end, right? Now np.random.seed 101, so for repeatability of this dataset, what we are doing is ABC, we are taking these for multivariate normal distribution, right, for all these columns, and we are taking size 100 for A, then 50 for B and 100 for C as well. If we combine all 3 ABC into data frame, so here we will get the 250, right, 100, 150, 250 by 2 rows and columns, right? So again samples with 2 dimensions. Now if we use it is telling that okay, use scatter matrix to print all these 3 distributions. So if you use the same, so here you can see that all the 3 distribution for each of the attributes or each of the samples. Next question, it asks that find out the linkage matrix. So basically use word as linkage matrix and distance as Euclidean. So we are generating the linkage matrix, so importing the linkage and dendrogram. G equals to linkage, x word, matrix equals to Euclidean, right? Z dot shape. So here 249 by 4, right? And here you can see that all these changes are there inside our array. Now plot the dendrogram of the consolidated data frame. So plt dot figure, fixed size equals to 25 by 10, dendrogram Z, plt dot show. So if you show that, here you can see that how you got your hierarchical clustering here, right? So here you can see for every samples you get that rectangle, the dendrogram for last merged clusters, right? So all these at the bottom. Now use truncate mode equals to last p attribute in dendrogram function to arrive at dendrogram. So yeah, this way we are defining this dendrogram Z that we got from here, right? This one, this, and then truncate mode list last p, basically it show only last merged cluster, right? P equals to true, that means only third we can say merged cluster. So here you can see our third merged cluster looks like. Now form the truncated dendrogram, find out the optimal distance between cluster which you want to use an input for clustering data. Max d equals to 50, use this distance, measure max d, and f cluster function to cluster the data into three different group. So from scipy dot cluster dot hierarchy import f cluster, cluster equals to f cluster z max d, criterion equals to distance and cluster. So here we got all this. Now use matplotlib to visually observe the cluster in 2D space. So simply we plot it as a scatter plot, right? Plot points with the cluster dependent colors. So plt dot show. So here you can see for all the data sets. So yeah friend, this was all about this hierarchical clustering on vehicles data. Hope you are getting the idea how we apply the hierarchical cluster and how what are the parameters that are required in this. So we'll come up with few more videos. Stay tuned. All the best. Thanks.